first, this linear regression thing again, because I think some of you still have a doubt. So we have these values on the x-axis, and we have the y-axis values. Okay? Now when we do a Pearson's test on these, we get something like this over here. Why? Because this one is an outlier. It's significantly larger than all of these. So the actual line was supposed to be something like this. You see 1, 2, 3, 4. All of these points are neatly covered with this. The distance is reduced, like it's the minimum distance it can be from these points. But this point over here, due to this, the whole line shifted upwards to minimize the distance. Now, once you rank this data, you get a line like this. Okay? So after I rank the data, this is the plot that I set up for this, and I got a line like this. Now, if you see this, the gradient of this line matches closely to the gradient of this line, right? Yes.
How does the ranking of data work?
Okay. So you have data that's of different values.
Yeah.
And basically you just assign it, okay? So you put it in ascending order, basically. Then that ascending order, you just give it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's it.
Yeah, I mean, how do we plot in the...
Yeah, so plotting it, I use a different y-axis over here, because it's not possible for me to draw like 70 on the board and this on the board as well. So I plotted it over here. The same thing, you just take the values that you have now, make a scale of it, and just plot it. The idea is that the ranking the data will give you, the outliers effect is now gone because this is the outlier, okay? This was the outlier, this is the outlier, some 55 is here, all the other values are over here, okay? All the other values for this are less than or around 20. This is the only outlier over here. This causes the whole curve to shift upwards. When we use the ranking data, you see how there's equal distance between all of them? You see this? So the difference, the technical term is increments. When the increments between these are eliminated and they're the same, the distance is like 1.0, 1.0, 1.0. This, the difference is like 8, 5, 5, 35. So you see this difference that's making our line distorted? That effect is now removed, because now we're using 5 instead of 55. So now instead of our value being all the way up, it's closer to the other values. So now this is the actual R, okay? Horrible handwriting. This is the deviated R. This is the RS. Now, if you see the RS and the actual R, you see that the gradients are almost the same.
Yeah.
Like the slope is almost the same.
Yeah.
That means that the R value will almost be the same. So that means that the deviation is no longer there. So when you rank it up, the effect of the outlier, which basically caused this whole problem, is gone. This is the simplest, like it's the easiest example to explain, but all of the non-parametric tests work on this principle. You just rank everything. You get the idea?
Yeah.
Is this clear now? Like, is there any question about this?
No.
Perfect. I know this is horrible, but yeah,
It's amazing.
the lines, the neatness, horrible. Okay, now the next lesson, there's 3 main topics that we need to discuss, or 3 main subjects that we need to focus on. First one is definitions. So basically understand, memorize, recall. The second thing is the types of biases. And the third thing is how do we take samples? How do we take samples. Now, over here, this is a really simple lesson, and it won't benefit you much, you just recall and stuff. But when you're doing an actual study, this is really, really important, because this should always be in the back of your mind. So for those of you who want to do research, understand this well, please. Okay? So, Dr. Hassan's favorite slide tells you basically what biostat is. Okay? Now, so this is a question that he gave you. You have no idea what's going on over here, but actually, how many of you can answer this right now? What is the answer? Perfect. Right. So exactly. So let's quickly go over everything. First, we go for definitions. Okay. Census. Census. I don't know if you have it in your country, but in my country, we had it like 20 years ago or something, where they basically go to every person's house and count the number of people. Census is basically counting the total number of people in a population. That's literally census. So over here, you may interview them, ask them questions, whatever. So the main reason for this is that there's no chance anymore, like there's no chance of excluding someone anymore, because you literally know everybody in the population. Countries do this to check their annual growth rates, the amount of population they have, they plan their budgets based on this and all of that. This is why we use it. It's not really relevant to our thing right now, okay? This is just the definition over here. Now, sampling schemes. Okay, so over here, let's just write this down for the time being. So the number of individuals in a population, we denote it by capital N. Number of individuals in a sample, we denote it by small n. Okay? Don't know how he's going to bring a question on this. Okay, so sampling units are the things we're interested in. No. Let's do this first. Target population. So target population is the population that we are interested in studying. So for example, we want to do a survey to find out how many students of COM in Al Faisal smoke. So our target population is all of the students from UPP to 5th year of College of Medicine. Okay? Now, sampling frame is the names of everybody in that list, basically. Now, this is the target population. There's another thing called study population. Study population is the number of people who we actually have access to. So for example, if I was doing the study, I wouldn't be able to go to all the 5th years because they're in different hospitals right now. So my study population would be reduced. So it's the population that I can actually do my study on. Understand? Easy? Now, sometimes this thing, sampling frame, it's actually for the target population. Sometimes, since we don't have access to all of the target population, they can use it for study population. Make sense? What else? That's it. Okay. So over here, study units. Now, our sampling frame was all the people of Al Faisal from UPP to all the way to year 5, right? Now, over here, study units are like, what are we interested in the population? So we said the number of students. Over here, it's the number of students. It could be the number of hospitals in a study. It could be the number of families in a study. Could be the number of pets they have, could be anything. So the thing we're interested in the sampling frame, that's study units or sampling units. Make sense? Okay. So these are the 4 definitions that you need to know. Now we go for biases. Now, basically you need to know their definitions and you need to know how they can be prevented, if they can. Okay? So selection bias. So selection bias is a bias when, what does it say? The selected may not be representative. Okay, so the line that it says a random sample, although representative of the population that is selected, may not be representative of the target population. What does that mean? That means that they took a sample just like this, right? And they found, which one is the first one? This. None of these are correct. Okay, so they found something like this, okay, which was representative, but it was representative of the study population and not the target population itself. Okay?
Yeah.
So it could be like the sample should reflect the target population, not our study population. Study population is the number of people we can study. Target population is the actual population we want to study. That's what this sentence over here is. Now, selection bias is bias when you have a systematic tendency to exclude individual members of the target population. So, for example, I'm a male, I can't include females because I don't have access to them. So they're part of the population, but for some reason they're selected, as in I'm not taking samples from them. You see? Or for example, the number of people who smoke, I'm excluding the people who use electronic cigarettes. You get it? So there's this one thing that I'm not considering while selecting the people. This is it. Okay, so random sampling is a method of sampling in which each individual has an equal amount of being selected. So if we go over here, if we had to take a random sample, it would be the chance of each individual being selected is the number of people in the population and the number of samples I'm going to take. For example, there is 1,000 people in the population, and the number of people I want to select is 250. This is my sample size. So if we divide 1,000 by 250, that means that there's a 4% chance for every individual to be selected. Does that make sense?
Yeah.
So if you have truly random sampling, then you have each individual has a 4% chance of being selected. If you have a non-random or haphazard selection, it means that this is not true. For example, I'm trying to find out the prevalence of obesity in a classroom or in a grade. Okay, so I go to each classroom. Actually, I make a list of all of the people in that grade, and then I use a computer program to just randomly select participants. So each participant has like a fixed number of chance of being selected. But now if I go to one classroom only and I take the first 5 people I can grab, that means that these 4 people had 100% chance of me grabbing them because they were closer to the door. The other people, like for some reason, they had a lower chance of being selected. You get the idea?
Yeah.
So everybody should have an equal chance of being selected. This is the idea of random sampling. So random error is what we're trying to, it's always there, you can't get rid of it. This is the the alpha value, the 0.05. The reason it occurs is due to random errors. Like it's just the chance of you getting something that's not significant. So in the same time, when you're sampling, it's the same thing. There's a chance that you're making an error, but you don't need to get rid of that because the error is random itself, so it cancels out. Does that make sense to you?
Yeah.
There's no selection bias. There's no systematic reason in which you're excluding a set number of people. Does that make sense?
Yes.
So random error is always there. We can't do anything about it unless my notes say otherwise. Yeah, okay, so to minimize this, you need good study design and good statistical analysis. This is for systematic bias. Yeah, so good study design and appropriate statistical analysis eliminates bias in general. What else? Okay, so for selection bias, you randomize. Because if you randomize, then you can't go only for females or something like that, What else? Okay, so we talked about selection bias, non-responder bias. So, for example, if a new number of people told you that they'll be part of this study, and after a while they just quit. So that's non-responder bias, as in you can't measure the effect on the people that aren't there anymore. So your sample size is reduced, so it'll have an effect on the study later. Yes.
Even with a good study design, you cannot eliminate random bias, right?
Random bias? Yeah, you can't.
It'll always be there. You can just eliminate the systematic bias.
Yes.
By randomizing.
By
By
randomization, yes.
making a good study design.
So in the beginning, when you're designing it, you need a good study design, which we'll talk about right after this. That's like the last part of this, actually the next lecture, which is the most important part of the next lecture, basically. Different types of studies. So non-responder bias, the patient does not follow up. Where is it? Yeah. Cannot be reached, could not participate, refused to provide the requested information. So this, you normally have this in all studies, right? Like the number of people who want to participate started decreasing. The only difference over here is that they're not answering for some reason. For example, if they had this one side effect to medication that was really significant and they stopped coming because of it. For example, they developed pneumonia due to a medication. So there's this one reason which we don't know, there's a factor that we don't know, which is causing a systematic decrease in the number of people. Does that make sense? Okay.
And you also said that it's mostly in clinical trials.
Yeah, it's mostly, but yeah, in anything that we require the consent of people to follow them over time, basically. Okay, so ascertainment bias. This is basically if like I know which drug actually works and I start giving that more to my patients. So it's knowledge of the treatment will cause you to subconsciously give the better thing more to get positive results. So you double blind for that. Easy? Any problem with that? Double blind means you don't know what the correct treatment is, the patient doesn't know what the correct treatment is. Recall bias?
Unconsciously, I'll start supplying them with a better thing.
Unconsciously. Like it's not, you don't want to do it on purpose, but you know which treatment is better and you know what you're giving to your patients. So to prevent that in all randomized clinical trials, they want it to be double blind. So recall bias is when you're doing questionnaires. So when you ask somebody, okay, how many hours of sleep did you have a week before? Like nobody knows that, but you just probably 5 hours, you know? You just say that. So it's not accurate. That's why we have a recall bias. So it's avoided by obtaining information from other sources such as hospital records, which have an actual record of what's going on, not just based on memory. What else? Other types of bias. Okay, so I talked about this. Every unit of the population has the same probability of being selected into the sample. Okay, so now the second part is, or the third part now, is the different types of sampling. So let's go over this really quickly and then we'll just go over the slides. So the first one is random sampling. Two ways to have random sampling. One, you have a calculator, you know those random number generators?
Yeah.
Either you do that or you like make a poll or something and just pick out randomly numbers, right? That's random. Systematic sampling is that, for example, let's open this slide. Systematic sampling is like you have a number of, you have your, what was it called? Sampling frame. You have a list of all the names of the people. And then you say, okay, I'm going to take every fifth person. So 5th, 6th, 11th, 16th, all of these are going to be included. Okay, that means systematic. So you have a pattern by which you're taking the people. It's not non-random because you randomize them in the beginning. Like you jumbled up the names in the beginning. Okay? Now the thing that I need to emphasize in this one is this. So you know how I said that every person will have 4% chance of being selected? That means that if I need a sample of 100 people, this. Okay, so if I have 100 people in a population and I want to take 10 samples out of them, so this is the number of samples. So I divide this by 10 and I get 10, right? That means that if I take every 10th person, I have like from 0 to 100. If I take every 10th person, then I'll be able to get 10. Does that make sense to you?
Yes.
Like I'm trying to find the what's it called? The factor by which I need to select the people. For example, I have a population of 100. I need 25 people. So what do? I divide this by 25. I know I have 4. So if I take people in increments of 4, so it's like 0, 1, 2, 3, 4, and then 8, and then 12. By the end of it, I'll have 25 people, right? So the idea is that to find the interval that you need to take, you divide capital N by small n, and then you select a number that's smaller or equal to it.
Okay, so you can't take 4.5 and 3.2.
Over here,
Yeah, that's what he needs in the last one, second last one.
so over here, it's 4, right?
Yeah.
So if it's 4, I can't take 5.
Yeah.
Like I can't take increments of greater than that because then at the end my sample size will be lower. So I have to divide it with a number that's smaller so that my sample size is larger than that. It's basic maths. So over here, this guy, he says, so starting from every 6th person, he had 1 to 10, so he had the option to take it from either 1 to 10, so he said, I'll take every 6th number. Now, the only reason I explained this is because in the past exams, there's been this really stupid question that makes no sense, in which he asks, okay, what's the sampling intervals that you'll take? And then there's one option that says 10, 20, 30, 40, and then there's another option saying 20, 30, 40, 50, which is the same thing. And then there's another option saying 6, 16, 26, 36, which is the same thing again, because the difference is only 10. But this is the right answer for some reason. I'm pretty sure he messed it up and then he didn't bother checking it later on. But this is the correct answer, just memorize it. It's going to be something that's not 10, 20, 30, 40.
In the class, he explained it as, for example, you have like this whole class, he was like, I will take 10, 10. First, I will divide the class into 10 groups.
Yes.
And then in that 10 group, every 6th person is going to be picked. So the first 10 and the first person, 6th person who's sitting in the first 10 group, that person is selected. Then the second 6th person selected. And then third 6th person. That's why the 16th position, and then the 26th position, and then 36th position. This is how we did it.
Yeah, that makes sense.
It's like you
But
choose a
the
random
question's
number.
wording is like,
Yeah,
it's weird.
Because like 6 is the random number between 0 and 10. So they choose 6 as like the random number and then 10 intervals after that.
Yeah.
It's like they're using the same random number for every person.
It's random of the random, except.
Yeah, so whatever, 6 could change, but 10 stays the same. You're dividing your class into 10.
But the idea is if he's starting from, for example, if he starts from 16, then that won't work. You
Yeah,
get my
because then
point?
you're the one picking the 16th person.
No, if it's like, if it's more than 10, if it's 11,
Yeah.
then it won't work.
It
Because you'll
won't.
have one person that's less.
Less, so it has to be within the 10th group.
It has to
Yeah,
be
it says
within the 10.
Yeah.
random number between 1 and k, which is 10.
Yeah.
And then he chooses
So
6 and then he goes in 10 intervals after 6.
basically, so the main idea is that the one that you're beginning with should be less than this answer.
But at the end of the day, if you're using an interval, it's not really random.
No, because you randomized the number of, like, you had a list, you
Yeah.
randomized that beforehand. So the idea is you don't know who the participants are, right? So there's an equal chance of anybody getting assigned number 6 or number 16.
Yeah.
You didn't put them in a specific order, like increasing age or
Yeah.
alphabetical or something. You just have a list.
So it's just a random sample or like random population, so it doesn't really matter. Like if you choose the first 50 people, they're still gonna be random,
Basically.
kind of.
Yes, but you don't choose the first 50 people.
Yeah, why not?
This is why you want equal it. because whenever you take a list, it's always going to be like numbered according to something. For example, if you have a list of classrooms or like people in a class, it's always going to be alphabetical order. So if you take the first 50 numbers, your bias is that you took the people like
people
who start with A from F, you know. So that's why we just set an increment that's going to have inclusion for everybody.
But I thought you just said the list is going to be randomized before you choose the number.
You can randomize. That's the idea, basically. Yeah. Either you
Like-
randomize the list or this. Thing
Or you
works.
randomize the interval, basically. Not the interval, you choose a number between 1 and k, and then you choose an interval after that number.
Yes.
Okay.
So.
So you do one or the other, you don't randomize the list and then get a random number.
You can do that as well. It doesn't matter. The idea is that you don't have this one thing that you're like, you know, you're preferring one way, you know.
Yeah, you're not
That's the
choosing
idea.
people based on height or anything.
This is just, for example, in a place where you can't use a computer generator, you only have this, you can use this. It's just a way of collecting samples that does not make a bias.
Okay.
That's basically it. What else? Characteristics, okay. Stratified sampling. So, stratified sampling is basically the same thing, but I made one category. You know how he said something about, Khalid said something about quasi-experiments?
Yeah.
Or quasi-randomization?
Yes.
This is exactly how you get that. So for example, you have a total population, and then you divide it based on gender, so you have males, and then you have females, and then you take random samples from this and random samples from this. So there's randomization is still there, but since we wanted to check the effect on gender, we separated these out. That's basically stratified sampling. Make sense? Okay. And the last one is cluster sampling, which you guys already know. So, for example, there's in stratified sampling, they should be mutually exclusive and collectively exhaustive. What does that mean? Mutually exclusive means that none of them are repeated in the two different categories. Collectively exhaustive means that you're covering everybody. You didn't leave anybody out while making them. Make sense? Obvious. Cluster sampling is that they form groups and then you study those groups. So they form clusters of population. This is usually seen in, if you're trying to study, if you have this area of land, and then you're trying to study the distribution of ants in different areas, basically. So they're going to be clustered in different areas, right? So if you take a sample from like this place, it's not going to be representative. But if you take a sample from this place, it's going to be kind of representative. That's why when we know that they're gathered in places, we use cluster sampling. Does this idea make sense?
How does it relate to clinics?
So you're not going on the streets and looking at people. You know that patients usually gather in hospitals. So you just check hospitals instead of going to every house and asking people, are you sick? Basically. Okay, so in this, what does it say? Okay, so once you obtain clusters, either you can do one-stage random sampling in which you randomly select families and then you check everybody in that family. Or you randomly select families and then randomly select people inside the families. So you do randomization twice in two-stage cluster sampling. Get the idea? What else? And yeah, basically we're done. No, yeah. Convenience sampling is the one I told you about. It's non-random. It's like, okay, so the number of people, the first 5 people who walk into the room, class, I'll select them. It's gonna make my life easier. And over here, the probability of an individual being selected in the sample is not known because he just randomly came in and I selected him. Yeah, that's it. Any questions about anything related to this? This is really simple. You just need to know the different ways. But this is actually going to be helpful once you start designing your own studies later on. Right now it's just pure memorization.
N over N capital over N small. Then, what is K basically?
What is K? K is the sampling interval that you need to make sure that the first number you select is below that. So you know how we said if there's 100 people in a population and you want to take a sample size of 10 and then you figure out how many people you need to select. So K is the value, like you guys told me, is the value that the first value you select should be less than K. For example, I need to find, so there's 55 people in a population. I want to find a sample size of 5 from this. So the number of people, so if we make, let's do it this way. If we make 5 groups of 11 people, I need to choose one from every group, right? For me to get a sample size of 5. Yeah. So basically, K is the number of, basically the first person you want to start with, his number should be either K or lesser than K, for you to be able to collect enough sample size. By sample size, I mean number of individuals in a sample. Wow, I just killed English right there. Why is it so hot in here?